Good afternoon. Am I audible? Sorry, I was late. There was some examination related issue. So what I was telling, yeah. Am I audible? If I'm audible, then I'll start like last class where we left. We left from permissible stress in steel and permissible stress in concrete. Okay, I think we left here. This one. My screen is visible. Design code, handbooks, and other references. Okay, so these are your codes. Okay, these are your design codes, handbooks, and other references which you will require in your structural engineering designs. So, IS 456 2000 is for what? These are important things, like you should know which IS code is what for what. Like IS 456 2000 is for plain and reinforced concrete code of practice of loading standards, right? So that means what? In this IS code, IS 456 2000, which we are using now, here we are having all plain and reinforced concrete code of practice and loading standards. All the things regarding your plain and reinforced concretes are mentioned here. All the that means like what are the specifications, how much size you have to take, how much reinforcement you have to take, what is the diameter, what is the clear span, or everything, what is the concrete type of materials we use in the plain cement concrete, in the reinforced concrete. So all those things are mentioned in your IS 456 2000. Now the next code of practice is which one? IS 875 part 1 to 5, sorry, part 1 to 5 is 1987 code of practice for design loads like earthquake loads for building and structures, second revision. Okay, that means IS code for reinforced concrete is what? Concrete RCC, reinforced R for RCC. The IS code which you follow is which one? IS 456 2000. Okay, but when you are dealing with earthquake designs or earthquake building designs, we use what? IS 875 1987 part 1 to 5. Okay, IS 875 is to 1987 part 1 to 5. What does these different parts specify? Like part 1 contains the dead load specifications, part 2 is for your imposed life loads specifications. What that means, what are the regarding your life load, anything and everything which you need to know, and which you have to take some rules and rules to follow. So those are mentioned in your part 2. Part 3 is your wind loads, part 4 is your snow loads, part 5 is your spatial loads and load combinations. Okay, now the next IS code, this IS codes which you have, right? So you will be obviously using, and these are from, if you're doing for your competitive exams also, these are important, like which IS code is for what. Suppose like for earthquake design, where we have to discuss for dead load and live load, which IS code will prefer. So we are going to prefer IS 875 part 1 to 5 1987. Okay, so next IS code is what? IS 893 1893 2002. This is the criteria for earthquake resistant design of structures. Okay, this is the fourth edition. Actually, this was also for your this particular one was also for your this thing, for your what? For your earthquake loads, but this had a revision. This one was a second revision, so another again some specifications were changed, or maybe there was because since we advance more in technologically, so there are some changes which we need to follow. Okay, like we need to maybe we need to increase the grade, or we need to increase the diameter of the rods for a particular purpose. So or earthquake intensity, maybe after some years, the maximum intensity of load, earthquake load, which was seen in your zone, like zone 5, was increased, or which you have to take the reference or something related to that, whichever is need to be revised. So those things are included, changes are made here, and then this fourth edition of your earthquake design IS is this one, IS 1893-2002. So when what is the IS code for your RCC concretes? Any kind of design is your IS 456 2000, IS 456 2000. Then we have IS 875 part 1 to 5 1987 for what? For earthquake loads, and this is the second edition. Then we have for the earthquake resistant design of buildings or structures. This is the fourth edition, 1893 2002. IS 1893 2002. Okay, then we have some design handbooks. Design handbooks are your steel tables, we call also to be steel table, like SP16 1980 is what? Design aids for reinforced concrete to IS 456 1978. Some of the specifications of IS, that means of the reinforced concrete, are mentioned here in your this SP16, that is the like you have some I section, you have T section, channel sections, which you use here. That will be the properties of that material will be here in your every property, like the thickness of the flange, thickness of the web, everything will be mentioned to you here in your SP 16 1980. Then we have one explanatory handbook on IS 456 1978, that is SP 24 1983. But basically we are going to use this SP 16 1980 for now for your purpose, IS 456, when we need to have the for RCC words. Okay. Then we have SP34 is there for concrete reinforcement and detailing. Then we have SP 23 1982 for your design of concrete mixes. Okay. So other relevant codes are what? IS 13920, ductile detailing of reinforced concrete structure subjected to seismic forces. So when you have seismic forces, okay, seismic forces are there, and you have to do the ductile detailing. So all the specifications are mentioned you here in your IS 13920 1993. Guidelines for concrete mix proportioning is what? IS 10262 2009. Okay, this you can remember, you have to remember which IS code is used for what. Then we have other reference books. Okay, these are your books. Then we come to your limit state method. Now we'll have what? We will have different methods. Like first of all, we need to know what is your IS. The limit state method. Okay. So for limit state method is what actually this is the acceptable limit for safety and serviceability requirements before failure occurs is known as your limit state method. Okay. Limit state method involves underestimation of the material strength and overestimation of external loads. For this, the method uses partial safety factor format. So, understood this thing? That means what this when we use this liquid limit I was saying. So, liquid state method limit state method. When we are using this limit state method, what is that? What we consider? We consider the we how we perform the limit state method, how we use the limit state method is what we underestimate the material strength. That means what? You will consider that the strength of the material is very weak, and in the accordingly you are going to design that. Okay, now suppose, and also one more thing, overestimation of external loads. Okay, so in limit state method, what we do, we consider that our this thing, the strength of the material is very less, or you see that it is less. Okay, just remember, understand, like we are considering that the material strength is less and with the external load is very high. Okay, your external load is bigger in size, or you can say like this, like just you maximum load or that structure can calculate or that structure can resist or take is how much, is suppose 500 kilonewton, I suppose. Okay, maximum is that. But what if it is more than that? Okay, suppose you want to construct a building and the load specified is how much you want. We will consider that your building or your structure, we will design in such a way that we will consider that that building has the maximum, you know, you that building has the max, that building will have to carry maximum load. Okay, so we will design the structure in such a way in the limit state method such that our building is taking the maximum load. Taking the maximum load, where we are going to design how much should be the sizes of the structural members like the beam, column, etc. Okay, so we have what? Then again, that means what? If we take more load, we consider more load for designing. That means obviously our structure will be safe, because the maximum load which you take for your design, obviously if it is maximum, that means it will be on your serviceability. When you're building, suppose for 10 50, suppose for 50 20 years you're building, you're constructing your building for 50 years suppose, so you have to give that serviceability, and you are carrying what, you are designing the building for 50 years. Now so that your building survives for 30 years, sorry 50 years, and it gives its serviceability, what we are going to do, we will design it in such a way so that it can take maximum load. Like sometimes suppose you have considered suppose 30 suppose 50 kilonewton, you have considered 50 kilonewton and you have designed. But what if sometimes earthquake load comes or very disaster happens, like you have constructed your building over the across the on the sides of the oceans, etc. Maybe there is if there is some tsunami or anything can happen in the natural calamities. So by chance if your load increases, that means you have designed your structure for 30 kilonewton, but if there arises some natural calamities or disasters, or externally only you are having some extra load on that, suppose on the terrace, on your terrace you are landing some helicopter or something like that, you want that. Okay, suppose so, obviously that means your load is increasing of that structure. Now life load, that is a life load, it is going to increase, right? But you had designed your structure for 30 kilonewton, so obviously your structure is going to fail, because extra load is going to come from the helicopter or anything. It can be earthquake load or wind load or a tsunami. In tsunami the water loads, etc., the force exerted on the buildings. So with respect to that, what we do, that's why what we do in limit state, we consider that what, that our load is maximum. We consider that this building can take this much of load, that means maximum kitna ho sakta hai, that much we take. Okay, like 500, agar if 500 kilonewton falls on this building, so that it can easily take that load. So in that your structure is designed in such a way so that if maximum load is also applied on the structure, it can take easily. Okay, that is your limit state method. In the limit state method we consider that maximum load. Okay, and we design, and we consider what, we underestimate the material strength. That means what, we consider that our the strength of our material is low, minimum, or it is less, it may not resist the material qualities. That means based on the material quality, the strength of your material is less. In the limit state method we will consider that our strength of the material is less, and in that way we are going to design. So when we design in such a way that we are considering that the material is weak, so obviously we are going to have more safety effect. safety factor of safety we are going to add to that, so that when extra load is applied, or if our material quality is also bad, or we had to compromise in some material quality, then it, so that your that structure resists or is able to resist those kind of extra loads. Okay, the materials as well as your structure. If your structural member will have a greater strength material, the materials with which a structural member is made, if that is good, is having a better strength, obviously your load will be, if it is more also your load, you're going to what, survive, your building is going to survive. So limit state method is basically what you have to follow two things in your limit state method, that is material strength is less and the maximum load. Okay, so we'll consider these two things, that this structure which you're going to make will should have this much, that means it may have this much maximum load, so we will design accordingly. This material is weak, so we can design in this way. Okay, the design of any structure should satisfy the following two condition. Now if we design our structure with the help of this limit state method, okay, one more thing here, this limit state method, everything you're going to get in IS 456 page number 67. Let me check. Mm, okay, I'll show you. I think I have shared with you this IS 456, so you can go there and check in page number 67. Okay, so now the design of any structure should satisfy these two following conditions, that is safety is okay and the serviceability is also okay. Serviceability, that means with due consideration to strength, stability, and structural integrity. If this condition is satisfied, the livelihood of or collapse is acceptably low under service loads, usual or acceptable loads, as well as probable loads. Extreme means, like I told you before in this point, that how we consider the safety, how we ensure the safety when we are doing in the limit state method, when we're designing something with the help of limit state method, how we ensure that the safety of the building by taking the considering the maximum load and the uh, lower material strength. Okay, so the collapse of the building may occur due to what, exceeding of the strength of material or load. Collapse may occur due to exceeding of strength of material or load bearing capacity of material. That means the load bearing capacity of the material is exceeding of the strength of the material or load bearing capacity of the material. Okay, in that case also your building may collapse, sliding of the building, overturning of the building, or any structure, not only building, any structure like your retaining wall can overturn. Okay, so or your building also may overturn. So buckling also it may happen. Your column may buckle, fatigue, fracture. So your structure which is designed accordingly, the RCC structure that can collapse if your these things occur. Okay. Limit state involves in collapse are called limit state of collapse, or ultimate limit state, which are defined for the following: fracture, compression, shear, torsion, and the serviceability. So basically, in your limit state method, we ensure safety and serviceability. If you design something with your limit state method, that means your safety and serviceability is ensured. Okay. So satisfactory performance of structure under service loads ensures no discomfort to the user, or if this condition is satisfied, then likelihood for user discomfort is acceptably low under service loads. User discomfort may occur due to this. Okay, deflection, cracking in your structures, walls. Sometimes it may vibrate too much. Durability, impermeability. Okay. Now there are some important terminologies which you need to know. So that is what characteristic strength. Characteristic strength, you already know what is that. It is the strength of the material below which not more than 5% of the test results are expected to fall. This is very important thing. Okay, characteristic strength is what? I think you may be asked also. You may have also been asked this question. So what is that? Your characteristic strength means it is that strength of the material below which, suppose your strength of the material is 10 kilonewton. Now below this strength, like suppose 10 kilonewton you said, now that it is a strength of your material. Now below this, if your material would have a strength of suppose less than this 10 kilonewton, okay, then what would happen? Not more than 5% of the test results are expected to fall. Okay, if the strength of the material is below, if the strength of the material below which, it is the strength of the material below which not more than 5% of the test results are expected to fall. That means characteristic compressive strength or the characteristic strength is what? That it is that strength. That means suppose 10 kilonewton, as I told you, suppose it is suppose 10 kilonewton. So this is that strength below which, suppose below this strength, that means 9 kilonewton, 8 kilonewton, not more than 5% of the test results are expected to fall. That means very less chances. That means only 5% of the test result. That means like suppose 10 kilonewton. Na? So below this 10 kilonewton, what will happen? Below this 10 kilonewton, only 5% is going to fail. Baki 95% is safe. Okay, that is that strength, characteristic strength. Okay, so characteristic strength is important. Why? Because below this strength, your 5% only, not more than 5% of the test results are expected to fail. Okay. Characteristic strength of concrete 28 days, characteristic compressive strength of 150 concrete cube is FCK, I told you before only. So for the design of structures, only 67% of FCK is considered. This is also important. Okay. Characteristic strength of reinforcement, still this is for concrete cubes. For design of structures, only 6.7% of FCK is considered. Characteristic strength of reinforcing steel is equal to how much? Yield strength of the yield, that means FY, or 0.2% of the prof stress. Okay, so that is your characteristic strength. You may be asked like what is characteristic strength? So characteristic strength is what? Below that strength, not more than 5% is going to fail. Okay, your test results. So this is very important. Then this characteristic strength, there are some specifications regarding this also. So there are loads which have 95% probability of not being exceeded during the life of the structure. Yeah. Magnitudes of these loads are enlisted here. That means dead load, live load. This thing's 1875 part 1, part 2. Here also I think we had discussed. This one. IS 875 1987. This one. IS 875 1987 part 1 is for dead loads, part 2 is for live loads, snow loads, part 4 is for snow loads, part 5 is for load combinations, IS 1893 is for seismic loads. Okay. We had two classes, no? Okay. I think I have some examination related work.